So today we are going to start mechanical properties of solids chapter. Then we have fluids. So these are easy weightage, means easy chapters where questions come very easy, direct formula and all. So go through these chapters. Fluid is also one of the most important chapter. And work, energy, power already I have delivered, laws of motion. So go through these lectures. Correct. Okay, let's start this mechanical properties of solids. See, suppose there is a rod like this or cable, a wire cable, this kind of cable, correct? You are applying some force F. What will happen? The cable will elongate now. The cable will elongate. Acha, like for example, I will take one example. Like suppose there is a balloon. If you apply some force and compress it little bit, compress. As soon as you remove your hand, it restores its original configuration. Correct? Means you are applying force F. Suppose balloon is also applying force F to restore. You applied force, suppose 10 Newton. Correct? And compressed it. At this time, balloon is also applying force 10 Newton, so that as soon as you remove your hand, it will go back to its original shape. This is clear? So this is called restoring force. Restoring force means a force applied by the body to restore its original configuration. Correct? Means if you are applying force F, this body is also applying force F in opposite direction at this moment. Suppose you are applying force F, this body is also applying force F in the opposite direction. That is called restoring force. So the body is also applying force F, same value. This F is called restoring force. Correct. Now, let's learn some of the parameters or technical terms related to this chapter. Suppose this is the cross section area of the body, cross section area. Then we define stress acting on the body equals to restoring force divided by area of cross section. Correct? This is the formula for stress. This stress is nothing but, one thing is clear na, that if you are applying force, restoring force is also F. If you are applying F force, restoring force is also F. So stress will be nothing but this force divided by area. Force divided by area. So what will the unit of stress? Force unit Newton, area unit meter square, Newton per meter square. And this stress unit Newton per meter square is can you tell any other quantity which has the same unit Newton per meter square? Pressure. Pressure is force by area. Okay. So it has the same unit as that of pressure. Correct. So if you want to write what I am saying, since this is a revision class, in one class we are going to complete the entire chapter. If you want to write at the same time. I will not give you time to write separately. Okay. If you want to write, or if you want just to listen, just to revise, so no problem, no need to write. But if you want to write at the same time. Correct. I will not give you time for writing. Okay. So stress is defined as force divided by area. Correct. Acha, what will happen if we apply force? the this wire will expand, it will elongate, correct? So what happens if we apply force? See, this is our wire. So if we apply force, we can see this is the increase in length. This much length it got increased. Suppose L was the original length, you applied some force. So this was the, till here it was the original length. This much there is increase in length. So when you applied force F, the length of this rod increased. This increase in length is suppose delta, and the original length of the rod was, correct. Then they defined another term as strain. What is strain? How much length is changing? Change in length divided by original length. Change in length divided by original length. And it will be like, see, dimensionless quantity, because this is also length, this is also length cancelled, dimensionless. So this is the formula for strain. So if you ask that what is the final length of this rod, so final length plus change in length, this will be the final length, L plus delta L, correct? So this is the final length, understood? Now we have one law which is called Hooke's law. Hooke's law, which states that stress is directly proportional to strain. Stress is directly proportional to strain up to elastic limit. Up to elastic limit. Or you can write stress equals to some constant into strain. Now 90% of the question, again you remember, 90% of the question from this chapter comes from this formula only. That's why this is one of the easiest chapter in class 11th. Okay? So stress equals to some constant times strain. This constant is called modulus of elasticity. Modulus of elasticity. Means if you increase the stress, strain will automatically increase. And you can feel how you can increase the stress. What is stress? Force by area. How you can increase the stress? By increasing force. If you increase the force, the length, change in length will also be more, na? Correct? You are applying more force. Suppose there is a wire, cable wire. You are applying more force. There will be more change in length. Delta L will be more, so strain will be more. So this formula you need to remember. The 90% of the chapter revolves around this formula. Correct? So they can give question like this. See. Suppose we have stress versus strain graph. And this is the graph for material A. This is the graph for material B. This is the graph for material A. This is the graph for material B. This angle is 30 degree. This angle is 15 degree, suppose. Okay. They are asking this modulus of elasticity value of K value of A What is the ratio of k value of A to the k value of B? Correct. Now, how to know what is the k value of A and what is the k value of B? See, you know now one thing, basic thing. See, basic mathematics I have uploaded. So you go through that lecture also. So what I'm saying, that suppose we have y versus x axis, and suppose there is a line like this. Right? This angle is theta. What is the slope of this line? Tan theta. The slope of this line will be tan theta. Tan theta. Tan theta, suppose I make one triangle like this. So this y by x. Y by x. Y by x. Correct. So means slope, we can write here that slope of this graph will be here in place of y we have stress and in place of x we have strain. And what is stress divided by strain? K value. Means if you have to find the k value, you should find the slope. Correct? Slope is nothing but k value. Means slope of stress versus strain graph gives k value. Remember all this. Slope of stress versus strain graph gives k value. To find the slope of A, k value of A means slope of A. Slope of A 30 plus 15, 45 degree. Slope is tan theta. You know, slope formula tan theta. So tan of 45 degree. This is the slope of A. Slope of B 30 degree. So tan of 30 degree. Tan of 30 degree. So this will be 1 by root 3. So finally answer will come root 3. This will be the answer. Correct? So these kind of questions they can ask in the exam. Okay? Okay, next. So again I am saying if you want to write, but at the same time you understand also and you write if you want. And the class is recorded, you can get the notes later on. You have apps and all, but you don't have device to take his help. If you are having device, you can see the notes there also. Okay? Next, see this stress, strain and all is divided in basically in three categories. One is longitudinal stress. One is shear stress. And one is volumetric stress. Correct? Volumetric stress. Now what are these things? See, whenever you are applying force and that force is perpendicular to the area, then in these cases stresses developed is called longitudinal stress. Like for example, the example that I took, like suppose this is the cable, you are applying force, so this force is perpendicular to this area, correct? This force is perpendicular to this area, so this kind of stress is called longitudinal stress. Similarly, suppose if you have a body like this, correct? This is the ground, suppose. And you are applying force. You are applying force in parallel to the cross section area. This is the area. Suppose, see, Longitudinal stress means you are applying force like this. This is the area perpendicular to area. When you are applying force like this parallel to the area, this is called shear stress. So when you are applying force like this direction, this will be shear stress. Here what happens now? Here what happens? This object gets little bit distorted. The object, it gets little bit distorted. See, like this. But you will observe that here the object gets little distorted. Like a free hand I will draw. The object's final shape becomes like this, little bit distorted. Okay. Suppose this is delta x, this length delta x, and this is L, suppose. And this angle, how much it got distorted is theta. Try to understand. This how much angle it got distorted is theta. This is length. How much length increased from here? This is x. Then we define here. See here, you know now stress is force by area. Here also stress will be force divided by area. Same. Here strain formula. Little bit it gets changed. Strain, how much angle it got distorted. So tan theta. Suppose theta is getting distorted, so strain will be tan theta. So tan theta, what we can write? Perpendicular by base, that is delta x by L. Delta x by L. So strain is tan theta, and theta is perpendicular by base, delta x by L. Now volumetric stress. What is volumetric stress? Suppose there is a container filled with water, and there is a like small football kind of thing. See, inside water. Correct. So what will happen now? What will happen? From all the sides, this water, this fluid will apply pressure. Correct. From all the sides, this fluid will apply pressure. Eventually, what will happen? The size of the ball will decrease. Okay. So here we call this stress. Stress is nothing but, here what we call stress is nothing but the pressure applied by the fluid. As a result, what happens? Volume gets decreased. The ball size will become like less. So here, how we define strain? Strain is how much volume gets changed, change in volume divided by what was the original volume of the ball. Correct. So see, all the cases you should understand. Like here, stress. In this case, what was stress? Force divided by this area. If this rod is circular in shape, area will be pi r square. So force divided by area. What was strain? Strain I told, change in length divided by original length. Okay? Similarly here, strain I told, what is the stress? Stress formula will be same. Stress formula will be same, force parallel divided by area. Here I told stress will be pressure and strain will be delta V by V. Whether it is they give you this case, whether they give you this case, whether they give you this case, In all the cases, main formula that Hooke's law is valid. That is stress equals to some constant into strain. In all these three cases, suppose this is case number 1, this is case number 2, that is shear stress, and this is case number 3. In all three cases, this is valid. Stress equals to K times strain. Correct? But you remember one thing, whenever they give longitudinal stress, whenever there is a situation of longitudinal stress, this K value we called by some special name, that is Young's modulus. Young's modulus of elasticity. Young's modulus of elasticity. Just a special name is given. Correct? Sometimes in some books you will see this K value is written as Y also, Young's modulus. Correct? Means what you can write, stress equals to Young's modulus into strain. So what was stress? Force perpendicular divided by area into constant, that is Young's modulus, into strain, delta L by L. This formula is very important, very important. Stress equals to, because 90% of the time they give question from here only, longitudinal stress. Okay? So stress equals to some constant multiplied by strain. From here what we can write, sometimes they ask what is the change in length, that if you apply force, what is the change in the length of the rod? You see change in the length of the rod, how much it is coming. This L will go there, so F by A, and this Young's modulus or this constant, Young's modulus is constant. So this is the formula for change in length. You can remember like that, falak. We have song na in Hindi, falak. I don't know how many of you listen Hindi song. Falak, you remember? Because change in length they ask most of the times. So falak, FL divided by AK. Now remember one case, I am not going to derive. Suppose there is a object, we are not applying any force. We are not applying any force, but it has some weight. Na? This object will have some weight which will act downward. So the weight of the object is W, suppose. So they will ask, due to its self weight, how much it is going to elongate. So I am not deriving again because right now there is no time to derive at all. Just you remember, the change in length will be same formula you have to write. In place of force you will write weight. But remember one thing. So this will be W, L is the length of the rod, by A, K, you apply one 2 here. This comes with derivation, integration and all things are there. Right now we are not deriving. Just you remember, due to self weight, if they ask what is the change in length, so W by 2AK. So this formula is also very important. Correct? Second, if we talk about shear stress, so same formula, stress is directly proportional to strain. Stress equals to some constant into strain. But here, this constant has a special name, and it is called modulus of rigidity. Modulus, like in longitudinal stress, it was Young's modulus. Here it is called modulus of rigidity. Modulus of rigidity, and sometimes it is represented by the letter G. Okay. So we write like this: stress, that is force parallel, divided by area, equals to constant, that is G, into strain. Strain was tan theta, and theta, or we can write F parallel by area equals to G, tan theta was delta x divided by L. This is the formula for shear stress. Correct. Next, so they make least questions from here, but they can ask. I'm not saying that they won't ask. They can ask, but they make least questions from here. Next, what they ask: volumetric stresses. Volumetric stress. So that ball example, ball is the fluid. Here the same formula will be applicable, that stress equals to K times strain. But again here K has a special name. This K is called bulk modulus. Bulk modulus. Bulk modulus, and sometimes it is represented by letter beta. Means what we can write: stress, that is pressure, equals to some constant, that is bulk modulus, multiplied by strain. Strain was what? Change in volume divided by original volume. Correct. And then you will see one minus sign. Why? Because change in volume, like if the fluid applies pressure, the volume will decrease now. So final volume will be less, initial value will be more. So change in volume will be negative. So negative will make pressure positive. Okay. So just to make it positive, like they apply one minus sign. So this formula is important. Sometimes directly they ask what is the bulk modulus. So bulk modulus, what is the right? Pressure. Bulk modulus is pressure divided by this quantity. Pressure divided by delta V by V. Minus 9 you can. Okay. This is the bulk modulus. Correct. And sometimes they ask what is the bulk modulus of a rigid, perfectly rigid, bulk volume of a rigid object. Achha, what are rigid objects? Rigid object is those objects which is not going to be deformed. They are rigid. Means I am not going to change. Means if you apply pressure, na, they will not change. Their volume will not change. So delta V will be 0. So if delta V is 0, so in the denominator, if anything is 0, anything divided by 0 will be what? Infinity. Anything divided by 0 is infinity. So bulk modulus is infinity for rigid objects. This also you remember. Rigid objects, or they call perfect solid. Perfect solid. Perfect solids. Right now, you want to or just. So always remember this thing, that bulk modulus of a solid, bulk modulus of solid is greater than bulk modulus of liquid, is greater than bulk modulus of gas. Right? Now they define one more term, compressibility. Compressibility. They represent by letter K, capital K. What is compressibility? This is the inverse of bulk modulus. Compressibility means how much you can compress. Out of solid, liquid, gas, how much, which object can be compressed more? Gas. Means compressibility Compressibility of gas is maximum, followed by compressibility of liquid, followed by compressibility of solid. So see, solid compressibility and bulk modulus are reversed. Here it is solid liquid gas, here it is gas liquid solid. So compressibility equals to 1 by bulk modulus. Correct. Then there is a term which is called Poisson's ratio. Poisson's ratio. Now, what is Poisson's ratio? You try to understand. That suppose there is a rod like this. You apply some force. So this long rod will elongate. Definitely this rod will elongate. But what will happen? It will elongate. It is fine. But this rod will become thin. Correct? If you have a rod cable, you are elongating. Finally, what will happen? It will become thin. Correct? Do you remember chemistry? We used to say ductility. If you elongate thing, and finally it will become into thin wire. Okay. So, what is happening? The length is increasing. The length is increasing, but the diameter is decreasing. Here diameter is more, diameter is less. So Poisson's ratio is defined as, I am writing here, Poisson's ratio this is nothing but lateral strain divided by longitudinal strain. So what is lateral strain? Means what is the change in diameter divided by total diameter? I think the diameter will change. So lateral strain is nothing but what is the change in diameter and what was the original diameter, this diameter of this object. And what is longitudinal strain? What is the change in length divided by original length. So this is Poisson's ratio. We represent by letter Q, Poisson's ratio. You can put one minus sign because change in diameter will be negative. Diameter is decreasing now. So change in diameter will be negative. So Poisson's ratio this is the formula for Poisson's ratio. Always remember that Poisson's ratio always lies between, you have any idea, minus 0 to 0.5. This is the limit of Poisson's ratio. It lies between minus 1 to 0.5. The maximum value can be 0.5, minimum value can be 1. Minus 1. Sorry. Correct? See, next we have this. You tell one thing. Suppose there is a body. We are taking the case of volumetric stress. If there is a football which is inside fluid, so fluid will exert pressure from all the sides. So what will happen? It will size will decrease. So density of the object. Density of the object is what? Mass by volume. Now mass will remain same, but volume will decrease. And if denominator will decrease, this whole fraction will increase. You know now, if this becomes less, whole fraction will become. So, on application of volumetric stress, what happens? This density increases. Density increases. Correct? So, suppose they ask that what will the final density? See, density formula again I am writing. This is the symbol of density. Density is mass by volume. Correct? From unit and dimension chapter, can I write? If you a little bit studied about unit and dimension chapter, again unit and dimension chapter we have suppose x equals to a to the power 2, b to the power 3 divided by c to the power 4. Suppose if you forget what was there in the unit and dimension chapter, for that sake I am telling you this. What we can write, delta x by x equals to, and this kind of questions they ask a lot. That's why I am saying go through that unit and dimension. Okay. This significant figures, rounding off, everything I have told. So delta x by x equals to, first we will write power delta a by a, then plus, then again power delta b by b, plus again power 4 delta c by c. But if there is any constant, so constant we don't touch. Constant we don't touch. See here what is happening. Here what we can write, delta rho by rho. Delta rho by, see the pattern, x, delta x by x. So here rho, delta rho by rho. Here mass is not changing, mass is constant. Suppose there is a ball, football inside a fluid. So fluid is exerting pressure. Ball size will become less. But nothing, mass will go. Mass will never go now. So mass is constant. Volume is changing. Volume is decreasing. So mass is constant. Constant things we don't touch. Volume to the power 1. So we will write 1. Power delta V by V. Delta V by V. Correct. So 1 you can remove also. 1 into delta V means you can write delta V by V. Now see, what I am saying, that delta rho by rho equals to delta V by V. And we know that from stress into strain, K into strain equation, stress was pressure minus constant was bulk modulus and strain delta V by V. Correct? So, if I write what is delta V by V, delta V by V, I can write pressure divided by this bulk modulus. This is the value. So, delta V by V will be pressure divided by bulk modulus. So, here we can write delta rho by rho equals to delta V by V, that is pressure divided by bulk modulus. So, delta rho equals to rho multiplied by pressure divided by bulk modulus. So, delta rho means final density minus initial density equals to initial density pressure divided by bulk modulus. What I told, what will happen? Density equals to mass by volume. Mass is constant, volume is decreasing. If denominator becomes less, the whole fraction will become more. Means final density will increase. So see, we can write final pressure divided by bulk modulus. So final density you can write like this also. Final density equals to initial density 1 plus P divided by bulk modulus. This formula you have to remember. Very important. They have asked so many times. Okay, that's why I have derived this completely. So final density means if you put any object inside any fluid, due to the pressure, volume will decrease. Due to the decrease in volume, pressure, density will increase. So what is the final density? So final density equals to initial density 1 plus pressure divided by volume. All these are questions. All these are questions of PYQs that I am discussing. Correct? Okay. See, suppose like there is, I don't know how many of you have studied that spring concept. Suppose there is spring. If you don't know, I will just explain. And you are compressing the spring. You are compressing the spring by X amount. You are compressing the spring by X amount. The spring gets compressed now. How much length? X length. So what is the potential energy stored in the spring? Potential energy stored in the spring is kx square by 2. Some students ask, sir, why there is energy? If we compress the spring, why there is energy? See, if we compress the spring like this, spring you have played now. If you have compressed the spring like this, you can feel now that spring is applying force in the opposite direction. If you put one ball, plastic ball or small ball, and reach to your hand, the spring will hit because the spring was applying pressure in this direction. So the spring will hit the ball, means it will apply force on the ball will displace. Means the spring has the ability to do work. And anything which has the ability to do work is called energy. Energy is the ability to do work. So here, if a spring is compressed, it has some energy. This energy, its formula is k square by 2. Correct? Whether it is compressed or whether it is elongated. Means if you disturb it from its natural length, either you compress or you elongate by x, the potential energy stored is k square by 2. Similarly, here in this chapter also, that if this is the rod and you are elongating it or you are compressing it, whatever you are doing, whether you are elongating it or you are compressing it, you are applying force. Correct? So here they ask what is the potential energy stored in the rod. So we have 2-3 formulas that you need to remember. Potential energy stored in the rod. F, that is how much force you have applied. Delta L, how much length increased divided by 2. This is one of the formula. F delta L by 2. Another formula. Potential energy. Half strength strain into volume of the rod. Half stress strain into volume. So these two formulas should be clear. Half stress strain into volume. So volume of the rod, what you can write? Like in this case, what is the volume of the rod? Volume can you write? Volume is nothing but area of cross section multiplied by height. So area of the rod multiplied by height, that is length of the rod. Class 9 10 basics. Volume is nothing but area multiplied by height. So what is the area of the cross section? If this rod is circular rod, so area will be pi r square. So area we can write pi r square into L. Acha, radius you can write diameter by 2. Radius of the rod, diameter divided by 2. So radius square means b square by 4. That's why area we write sometimes pi by 4 b square into length. This is the volume. This is the volume of the rod. So sometimes they give in the exam directly diameter. So don't waste time by solving this radius. You are converting into diameter that time. Pi by 4 b square. Okay. So sometimes what they do, see, they give that one example I am taking, like stress value they have given 10 units. Correct? Young's modulus of elasticity they have given 2 into 10 power 5. Suppose, for example, just example I am taking. Volume they are given 2 meter cube, volume of the rod. They are asking what is the potential energy? Potential energy of the rod. Can you solve? Potential energy. See which formula you have to apply. I have given two formulas. One is force delta L divided by 2. There is no force here in the question. So let's apply second formula, that is half stress strain into volume. So half stress is given how much? 10. The problem is strain is not given. How you will calculate strain? By the basic formula. What is the basic formula? Hooke's law. You remember, stress equals to some constant into strain. This is Hooke's law. This is nothing but Hooke's law. Correct? So strain is not given. So strain, can you write strain equals to stress divided by constant? Stress divided by constant or Young's modulus. Here they have given Young's modulus. Strain equals to this constant will go down. Stress divided by stress is given. Strain equals to stress. Stress is 10 divided by this constant, that is 2 into 10 power 5 multiplied by volume. Volume they are given 2. So this will be the answer. Correct? This will be the correct answer. Okay. Now see, there are two words. One is elastic versus another is plastic. What is elastic? Suppose there is a rubber band. Think like there is a rubber band. You have cut the rubber band. It's a straight rubber band. You are pulling the rubber band and you release. It will come to its original shape. It will come to its original shape. Correct. So when it is coming to its original shape, this is called elastic nature. You see now this band is elastic. If you pull, then you release, it is coming back. Correct. Suppose this is a cable wire. You pull little bit and you release, it will come to its original shape. Original shape. So this nature is called elastic nature. Returning back to original shape. Plastic is just opposite. When it does not return back, it is called plastic. Means you applied some force. Think like this. This is a bottle. With the help of any machine, I apply some force. Its length will increase. Now if I release, will it go back? No, it is not going to go back. Suppose you are playing with clay. You molded it like this, you increase the length. Now you release your hand, will it go back? No, it's called plastic. And between these two, like suppose you are there are some objects, when you increase, when you apply the force, and when you release, it comes back, but not to the original shape. Understood? Means suppose there is object like this, you apply force. So what happened? Its length increased. Now when you release the force, it is coming back. It is coming back, but not to the original shape. Little bit it is coming back. Understood? This was the original shape till here. This was the original size. Once you increase and then you release the force, it is going back. It is going back, but not to the original. So this is between elastic and plastic. This is called yield between elastic and plastic. Correct? So we have a graph for ductile materials. Ductile materials, I am drawing stress versus strain graph. This is stress, this is strain. Means they did the experiment, they increased the value of force. This rod, suppose there was rod, they are increasing the force. So means they are increasing the stress. So if they are increasing the force, length will also increase. So strain will also increase. Stress is directly proportional to strain. And they did the experiment with ductile material. Remember. Now how the graph look like? See the graph. Since stress is directly proportional to strain, the graph will be straight line up to some point. Graph is like this. See, from O to A, Hooke's law is valid. I am writing O to A, Hooke's law is valid. From A to B, see, you are increasing stress, strain is also increasing, but it is not straight line, it is curve. From A to B, the graph is curve. Means it is not directly proportional. Means when you are increasing this is also increasing, but not in the same proportion. So A to B is curve. Then the graph falls down. And finally, see, the graph is like this. This point, this C point, this C point is the ultimate stress. Ultimate stress. What is ultimate stress? This is the maximum stress that a material can tolerate. Correct? Maximum stress, suppose I am beating you. Okay. So maximum how much you can tolerate, maximum how much your body will tolerate. After that, you will become unconscious. If someone beats someone, taking that negative example, but try to understand. Suppose some 3-4 person are beating one person. So here's the maximum limit. Sometimes it will fall, it will become unconscious. So this is the ultimate stress. And you are pulling and pulling, you are applying more force, maximum. The body has the ability to tolerate. So this is the ultimate stress. At this point, D. D is called failure point. Failure point means the material breaks. It's finally you are dead. Again, they are repetition. So this is called the failure point. Failure point means material breaks. Correct. One important thing that you have to understand, that ultimate stress is more than the failure point. If they ask which stress is more, the stress at the ultimate point or the stress at the failure point. So the stress at the ultimate point is more. Means you just think like this. I have tried 100 meter. Now you fought back a lot. You tried to struggle. You are also fighting. I am also hitting. But I applied more stress and finally at 100 unit stress. For example, just example I am giving. I applied 100 unit stress. Now you are unconscious. Now you are not able to do anything. Now even I applied 10 meter and I do this with less stress, I can kill you. No? Not you, don't worry. Just giving one example. I applied more stress. I hit you very hard. First, I made you unconscious. Correct. So I applied 100 units power and I made you unconscious. Now, when you are unconscious, even if I apply 50 units less power, you will die. Correct. So that's why this is ultimate stress. It is the maximum stress that the material will tolerate. And failure point is, this is the failure point. D is the failure point. Failure point is little bit less. Means with less power you can break the object. This from O to B zone. This is called plastic zone. Means when you are applying the force here now, you are releasing the force. The material will come back to its original position. From this point, suppose I name this point E, or from here to here, excuse me, this is yield, means material will come back but not to its original shape. And finally from C to D, this is plastic zone, means the material is not going to return back even little bit. So I define elastic, plastic and yield. So this is elastic, sorry, not plastic. This is elastic. This is elastic zone. Elastic zone. So this graph you remember. Okay. This is E point. You can write this is yield point. Correct. Then we have this graph for brittle materials. Brittle materials. Brittle materials, you know, no? The materials that break, they will not turn into thin wires. They will directly break, like glass. Glass will not become like thin wire. Suppose there is a glass, made of glass. I am trying to apply force. So suddenly it will break. Okay, it will not turn. So for them, the graph is little bit simple. This is stress. This is strain. The graph is like this. Okay, fine. The graph will be like this. Means there will be no failure point, no ultimate means yield zone and all. Directly it will break. This is also discharge. Okay, no problem. So what I am saying, for brittle materials, the graph stops here only. Correct? Because there will be no like yielding, there will be like directly it will break. Means if you are increasing the stress, after some times finally it will break. Means you achieve the failure point, like here it is breaking. The failure point is achieved much earlier. Correct? We don't have that much long graph. We have shorter graph. Correct? So this is important. So these are the important points of this chapter. This chapter is very short, relatively easy only. What things you have to remember? First is this, that for what kind of questions they ask, I will tell you. That this is a stress strain curve. They can ask that whether this zone, this is elastic, plastic or yield. So this is plastic, middle one is yield zone, last one is plastic zone. Then they ask failure point and this ultimate stress. Which is the failure point? So this is the failure point. Here material will break, and this is the ultimate stress point. Here maximum tolerate, the maximum stress that the object can tolerate. You can see the graph is too much long. Correct? Failure point is too much far. But in case of brittle materials, this failure point is here only. It is near only. The graph is not that much long. Correct? So this is the case of brittle materials. So this is one of the example or one kind of question they ask. Another, this that question based on this potential energy, half stress strain into volume. Sometimes they ask potential energy per unit volume. Potential, what is will the potential energy per unit volume? Per unit volume means this volume you keep this side. Potential energy per unit volume. So half stress strain. Or they will give these things, F delta L by 2. As a delta L, how to calculate delta L? That formula, Falak, FL divided by AK. Then we have this, very important, that if the object is inside any fluid, it will exert pressure, volume will decrease, density will increase. So final density will become initial density, bracket 1 plus pressure divided by bulk modulus. Then we have this Poisson's ratio, lateral strain divided by longitudinal strain minus delta D by divided by delta L by L. How much diameter is changing? Divided by original diameter. How much length is changing? Divided by original length. Its value, maximum value 0.5, minimum value minus 1. Then compressibility, gas is maximum, liquid is then middle, and the solid compressibility of solid is minimum. And compressibility and bulk modulus are just reverse of each other. So bulk modulus of solid is more, followed by liquid, followed by gas. Then this formula for volumetric stress, that pressure, that is stress, equals to some constant, that is bulk modulus, divided by strain, multiplied by strain, delta V by V. So they can ask bulk modulus, so bulk modulus will be P divided by delta V by V. All these are questions only, I am saying. Just they will give you values. For shear stress, we can write stress force, parallel force divided by area equals to constant, this is G, multiplied by strain, tan theta or delta X by L. For longitudinal stress, force will be perpendicular to the area equals to some constant, that is Young's modulus, multiplied by strain delta L by L. From here delta L, FL by AK, because they ask most of the time this formula. So directly remember this formula. As due to the self weight, how much elongation in the rod? So WL by 2AK. So all these things were the important points. Go and solve the questions, PYQs of NEET and all. Okay, go and solve the questions. Whatever doubts you are having now, we can discuss later, like after the class. Because these classes I will just revise the concepts. Okay, because in 1 hour we can hardly solve 3-4 questions in physics. So you solve later on, but I will tell you all the concepts. Correct? Okay. Thank you. Thanks a lot.